Alright, in this video I'm going to be showing you guys how to do the sum and difference of cubes. This is just a method of factoring where you're doing nothing but using the formula. So the hardest part of this truly is recognizing when to do it and remembering the formula. Alright, here they are. Here are the formulas. Whoops. For these things here, alright, what we're saying is if I have some number A and I have that thing cubed, and I'm adding that to something B, which is cubed, all I would have to do here is, let's say I had my A in red, is I would just take my A value and just kind of, so actually let's say it's in blue, my B. All I would do here is just pop A in, square it, multiply it, and I would do the exact same thing in with B. So that's all that you're going to see me doing here. Alright, so if I had a B here, well, I'd have B, and the B would go here, and then the B would be squared here. That's it. So the thing you should be looking for really are the perfect cubes. Okay, perfect squares, you guys learned those, way back in the day, and they're not terribly difficult to remember. Perfect cubes are a little different. 1 cubed is obviously going to be 1. 2 cubed is going to be 8. 3 cubed is going to be 27. 4 cubed is going to be 64. 5 cubed is going to be 125. 6 cubed is going to be 216. And 7 cubed is going to be 343. Really, the best thing I can recommend to you is to look for these numbers. Okay? When you see these or some kind of cube, that's when you're in a pretty good spot. Perfect squares, you get used to identifying those, and then you can identify different squares. It's the same type of thing with difference of cubes, and sum of cubes, rather. Alright, so this is my, just to be clear, this is my sum, and this is my difference. Obviously, because this is a difference, and this is a sum. Alright, so let's do the first example. Alright, so we're going to factor this one completely. As with everything, first thing I should consider is my GCF. Always start with GCF. And just by looking at this, I see that these both have a 6. See, this is a to the 4th, AB cubed, so I've got an A. And now, after I take that out, what I've got left is A cubed, plus, if I take a 6 out of 48, I'm left with 8, B cubed. Alright, I see an 8, I see the cubes, and this is a sum. It looks like I'm looking at, obviously, a sum of cubes. So what I'm going to go ahead and think about here is I'm going to think about something cubed plus something cubed. And then I've got a lot of stuff that I need to know. So really all I'm going to be doing here, since I'm thinking about a sum, alright, we'll talk about exactly what goes into these certain places here in a second. Think about what, when cubed, gives me A cubed. Well, that's obviously A. No question about that. And in the case of 8B cubed, alright, well 8, that means there's going to be a 2 here, because 2 cubed gives me 8. B cubed, a B is going to go in here. Alright, so now I know the first value, and I know the second value. So now I go ahead and I set up my parentheses. Okay. And I had the plus, because it's a sum. And where am I coming up with this? Well, since I see I'm looking at the plus, I'm looking at the sum. Okay, so I'm going to start with the sum, difference, sum. The way you can remember this is same, opposite, always positive. Okay, Same sign, then the opposite, then always positive. Okay? See the same thing here? Same, opposite, always positive, because these are the same. And these are opposites, and this is always positive. So now I'm just using this formula. So now this first thing, cubed, okay, so what I'm going to go ahead and do now is just put that a in here, because that goes here. And then it was this thing squared. I have this thing multiplied here. Now I put the b in, or the 2b rather, I'm sorry. So that goes here, and that goes here, and then I've got that thing squared. Alright, so now I'm just going to go ahead and simplify here. So I've got 6a. That's not hurting anybody. Well, alright. I don't need all the different colors now. So a plus 2b. I don't need to simplify that at all. A squared plus a times 2 times b. I could just go ahead and write this as 2ab. 2b squared is going to be, well, 2b squared is 4b squared, if that makes any sense. Alright. And that is how we do the simple ones. So, I'm going to go ahead and write the formulas out here just to kind of make life a little bit easier for me. Let's say I use m and n. And this is for no other reason than to just kind of have them in front of me, because last time I can imagine that this would look super overwhelming if you didn't know what you were looking at. And see, I can do this because I've memorized the formulas. And yes, I can understand that you know, it may seem just totally impossible to memorize it, but obviously I haven't memorized them that well, or else I wouldn't have gotten that part wrong. But it just takes time, it just takes practice. And the good news is that this is easy enough to where you can just practice and practice and practice and practice, and you don't have to like lock yourself away in a monastery or anything like that. Which is good news. You hate to see students doing that. Alright, so there's my formulas. I'm just going to go ahead and keep these off to the side. Alright, so I'm going to start with my GCF. Well, I can tell just by looking at this thing, there's not going to be one. Okay, this thing has 6 x's, 12 y's, a 64. No GCF. But truth be told, I mean, that kind of actually does make things easier for me. So here's what I'm going to do. I'm going to go ahead and look at this thing. I'm going to see relatively quickly. 64 is a perfect cube, and so is x to the 6th. So let's think about this. At 64, what did I cube to get that? 4. X to the 6th, what did I cube to get that? X squared cubed. And then I'm going to go ahead and think of the same thing with the second part. Y to the 12th. Well, what did I cube to get that? Y to the 4th cubed. Alright, so it looks to me like we're looking at a difference of cubes. These are cubes. Alright, cool. So now I'm going to go ahead. Same. Opposite. Always positive. Okay? Alright, so now I'm going to go ahead and put that first m value in, or a, or whatever it is we started with. So I'm going to put these in first. So I've got 4x squared, and then 4x squared squared, and then 4x squared. Okay. Now I'm going to go ahead and put my y to the 4th in. See my y to the 4th. Y to the 4th times y to the 4th, and then whoopsie, y to the 4th squared. Alright, so now I go ahead and explode this out. So 4 squared is 16, x to the 4th. Alright, and then this is going to be y to the 8th. Alright, so now what I've got here is 4x squared minus y to the 4th. 16x to the 4th plus 4x squared y to the 4th plus y to the 8th. Alright, so it looks like we're done, and we can pack up and go home. But there's something really, really cool happening here. This right here is actually another method of factoring. And this is I know that this is actually going to be 2x squared, and I can think of this as y squared squared. And this is a difference. So, it looks like I'm looking at a difference of squares here. So, let's go ahead and do that. And so, as I left off, I had 4x squared minus y to the 4th, 16x to the 4th, plus 4x squared y to the 4th, plus y to the 8th. Is that right? Yeah, cool. Kept going. Alright, so, as I said before, this right here is technically 2x squared minus y squared squared. So now I can actually take this thing here and I can blow this up into a difference of squares. So now I get 2x minus y squared and then 2x plus y squared. And now that black thing, for all intents and purposes, I'm not going to be factoring that anymore, so I can bring that down. Alright, and this is my final answer.